You know, it is super useful for being able to see what your shader is actually doing. Over here we have the colors, so let's get rid of the preview right now. And in order to make it work, we really just need to connect the RGBA and go up here into the base color. And right away it should work, but you might not be able to see anything over here on the main preview. I believe this is a rendering bug in the current tech version, so right now nothing is shown. So if you still don't see anything, it's actually pretty simple. Just go up here on the top left side and make sure to save the asset. Okay, save it, great. Then let's exit from our maximize view. And now let's close this tab. Let's click on play just to play the game. Now let's stop playing. And now if we open the shader again, yep, there you go. Now we do see the shader compiling over there, that color, that is the shader compilation. And after a little bit, it should work. Let's just maximize this. So there you go, there we do see our texture. Okay, great. So again, this is just a simple rendering bug on the current tech version. If you're watching this video in the future, chances are you don't even have this bug, so there's no need to worry. Okay, so right now we do see it working. We can see our bread texture, and it's currently being applied on a sphere. For our use case, we're working with 2D textures, so this would be best to be seen on a quad. So we can right click over here on the preview in order to select the preview mesh. So let's go with a simple quad, and yep, there it is, we have our nice quad. Okay, great. So over here we have our basic shader. All it does is just shows a texture, that's it. Now let's actually use this. And first, let's always make sure to save the asset. On the top left side, on the moving visual, if you see an asterisk here, that means you have unsaved changes. So always make sure to save them. In my case, I don't, but still, never hurts to save. Now over here in scene view, let's go inside our delivery counter, so let's open it. And now for the display for our arrow, let's make it a flat quad. So let's right click in the hierarchy, let's create a new 3D object, and let's make it a quad. Let's call this the delivery arrow. Let's place this on top of the counter, so let's rotate it to face upwards. By the way, on the rotation, make sure the color is facing upwards. Most shaders by default, they only render one face and not the other one. So make sure you put the face with the color upwards and not the other one. Okay, so let's rotate this one upwards. So there you go, 90 over there. And let's just put it just exactly on top of the counter, so just enough so that it's visible. Okay, great. So now let's make a material for our arrow. So let's go inside the materials folder, and over here, let's create a brand new material. Let's call this the delivery arrow. Let's make sure to use this material on the quad, so let's just drag it over there on the mesh render. Okay, so it's using our custom material. And over here on this shader graph drop-down menu, over here we can select what shader we want to use. So in our case, let's go inside the folder shader graphs, and inside, yep, here we have our moving visual shader. So let's go ahead and use this. And yep, right away we do see that it does work. Here we have our texture being drawn exactly on top of our material. Okay, so far so good. Now again here, remember one very, very important thing that I said. The texture that you define the shader, over here the default for the property, this one is only the default. The important one is the one that we have on the material. I'm emphasizing this point because I've seen a bunch of people make this mistake. If you modify the default texture whilst inside the shader, like for example, if I change here from bread, let's say into the cabbage slices, if I modify that, note how it does not modify any materials that were created. We are only changing defaults. So if you want to change the texture that is actually used, make sure you change the one on the material that you created and not the default. I changed the default but did not change this shader. However, if I now were to make another material, which by the way, here's a quick tip, you can right click directly on the shader file and go into create and create new material, and it will automatically create the material using that shader. And actually here it didn't update default just because I didn't save the shader. So I modified this one for the cabbage slices, and now if I save the asset, and now if I right click there and I create a brand new material, and yep, now that one does have the new default. But again, remember, what you set over here is just the default. What really matters is what is on the material. After the material has been created, modifying the default here does nothing. So always keep that in mind. In most cases, you want to be changing the property on the material itself, not the default on the shader. Okay, let's just clean up both of these. All right, so let's continue. Now here we have our sprite working, okay, except we don't want to show some bread, so let's actually use the proper arrow sprite. So let's select this one. And yep, it does work, it is printing the sprite. However, one obvious thing is that the arrow is not transparent like it should be, so let's solve that. Back in our shader graph, in order to make this a transparent shader, we need to actually go into the graph settings. So in the graph inspector, go into graph settings, and over here you see a bunch of settings that relate to the graph itself and not any selected property. So let's go into graph settings. For example, like I mentioned a while ago, you can modify between lit and so on. So this is where you would change that. You can also up here add multiple targets. So you can create a shader in shader graph and make it work with the universal render pipeline or the high definition render pipeline or the built-in render pipeline. All of those are supported through shader graph. Now for our goal, in order to make this a transparent shader, let's just go over here onto surface type. Instead of opaque, let's change to transparent. And as soon as we do, look what happens there. And if there we go, it adds a brand new alpha channel. If we just save the asset right now, and nope, look at that, it still doesn't work. It's still not transparent. Basically, we made this shader transparent, but now we need to feed in the transparent channel over here onto the alpha. This is the one thing that is different from a previous version of shader graph. Previously, you could just feed the alpha channel over here onto the base color, and shader graph would automatically apply it. But in recent versions, you need to add it over here separately. So if you have any issues with transparency when following some older shader graph tutorials, always remember this change. I covered that along with some other changes in a very useful video. So if you're following along some older shader graph tutorials, make sure you watch that video to learn what you need to do to update them to the latest version. Okay, so here on the symbol and texture, we already have the alpha channel, so we just connect this onto the master alpha. And right there, we already see it working. Let's just go ahead, save our asset. And here in scene view, yep, there you go, now we do see our arrow. Now, one more small thing. You might notice that from some angles, it's not exactly transparent. Basically, it actually is transparent, but since we made this a lit shader, sometimes the light might make the transparent parts visible. One option to solve that is over here on the graph settings. Instead of making it lit, let's make it unlit. That would work. So yep, with the unlit shader, the transparency is perfect. But if you really want to keep it lit, then the other thing you can do is just over here play around with these settings. You've got smoothness, AO, and so on, and over here you can even modify the workflow mode. So for transparency, instead of making it metallic, let's go with a specular workflow. And then over here, set the smoothness to 1 and the ambient occlusion down to 0. And now if we save this shader, and look at that, and yep, now the transparent parts are indeed fully transparent. Finally, over here on the right side on the mesh render, if you want, you might want to play around over here with the cast shadows. So maybe you don't want this one to cast shadows, maybe you don't want it to impact light probes, and so on. Okay, so with this we have our nice transparent arrow. Let's make sure to save our delivery counter, so let's go outside back into scenes, and let's hit on play. And yep, there you go, we have our transparent counter with our nice arrow. Now we want the arrow to actually move. And doing that is actually super simple. Going back here in our shader graph, let's just modify default just so we can see the arrow that we want to see. So let's select the arrow sprite. Okay, there's our arrow. Now for moving, over here on the simple texture, we've got an input for the UV. The UV is what defines what portion of the texture we're going to grab, which by default just gets the whole texture. So since this field represents where we're going to grab from texture, by playing around with this we can grab different parts. So to do that, let's just add a standard UV node. So here it is. This is the standard UV channel. So if we connect this, then nothing changes. Everything still renders exactly the same. But now we can modify this. And to do that, we're really just going to use some basic math. Remember that when working with shaders, even though you do see colors, everything is really just numbers. So a UV2 is just a number, the color is just a number, the alpha is just a number. So visually, everything might look like images, might look like colors, but really in the end, it's all just numbers. So for example, how do we move this texture? Well, it's actually pretty simple. We just add a number onto it. So over here on the UV, let's just add an add node. So this just adds two numbers together, very basic. So let's take the regular UV and let's add something on top of it. For example, we can make a vector 2 and let's put it on, say, 0.10. And let's add this one onto this one. And now if we drag this one onto the input, look over there on the preview what happens. And if there you go, look at that, it moves slightly to the left. So if I modify this one, put it on 0, there you go, at that, 0.1 on that, 0.2 on that, and so on. So you can see that by modifying here, I'm essentially offsetting the texture. I'm offsetting on the X, and over here I can also offset it on the Y. Basically, I'm offsetting the texture by 10%. The UV is a normalized value. This is not pixels. So that is why 0.1 is 10% regardless of how big the texture is. And if we go way past 1, then the texture essentially loops back. So this is really all we need. For our moving arrow, we're going to have 0 on the Y, and on the X, we're going to constantly either increase or decrease. That's how we're going to have our moving arrow. So again, the only issue here is that I'm modifying this manually. We don't want a fixed amount on the shader. Instead, we want a nice animation. So for that, we have the very useful, the time node. This one has various time-based outputs. The one that we want for this case is the time, which is just the total time. This one is constantly increasing since the start of the game by the number of seconds. So if you use this over here directly on the add, and there you go, look, that texture is constantly scrolling. Okay, so that's great, except obviously we have one issue. We don't want it to scroll diagonally. We only want to scroll in one direction. So for that, we can essentially create a simple property to act as our speed. So let's over here on the blackboard, let's create a new vector2, call it our speed property. And for default, let's default on say 0.1 on the x, 0 on the y. And now if I drag the speed over here onto our blackboard, okay, great. This is basically a multiplier, so we just need to multiply the time by this. So let's add a multiply node. Also, by the way, quick tip over here on each node, you've got a nice little arrow. So if you want to make it a bit more compact, so if you don't actually need to see the preview, so make that. And in this case, let's take our time, multiply by our speed, and then for the output, pass it into the add. Okay, so look at that. Now it is indeed moving in this direction. And over here on the speed, we can play around the values. So if we put it at 0.5, now it's moving faster. And if I put it on the y, now it's moving diagonally, put it 0 on the x, and now it's only moving vertically. Okay, so this is really what we want. Let's just go ahead, save our shader, and now let's just select our delivery arrow material. And over here, yep, we've got the speed. If you don't see it, make sure that on the speed property over here, you have it exposed. So we have the speed, instead of moving on the y, let's move on the x. And actually like this, it's reverse going backwards. So over here, we can just put a negative value. So let's put it on -1. And if there you go, now the arrow is moving perfectly. Also here, let me make one important note. Just in case you're using this shader with a custom texture instead of the one included in the course, if you do that, make sure that the texture that you use, so over here I'm using the arrow texture. Over here on the arrow import settings, down here under wrap mode, make sure it is set to repeat. If you set it as clamp, you might get some weird visuals or nothing at all. In order for the texture to constantly loop and constantly repeat itself, that one needs to be set to repeat. Okay, so here it is in game and we have a really nice moving texture. For that, we created a simple but really nice, useful custom shader. Definitely go ahead and watch the various effects that I made in the shader graph playlist. This tool is super useful, definitely make sure you know how to use it. I've used it for making a building effect, I've made some nice outlines, a really nice wind shader, also a really interesting dissolve effect, and even a cool transition shader just like in the game Hades. So this really is a super powerful tool, make sure you watch that playlist to really learn how to use it. Alright, so here we learned about shader graph and created a really nice custom shader. However, the delivery counter still only has a visual, so let's create some proper logic for generating and delivering the correct recipes in the next lecture. Hello and welcome, I'm your Code Monkey. In this lecture, we're going to build a proper delivery manager that will generate recipes that the customers are ordering and validate to see if the player made the right dishes. Alright, so right now we have the player capable of making dishes. So for example, I can put some cheese, cook some meat, cut the cheese, and then pick up both of them. Then let's say pick up some bread, and there you go, got a nice cheeseburger, and deliver it. Okay, so that works, but right now they just vanish on the delivery counter. So there's no recipe we need to follow, no validation, none of that. So let's add both those things. Okay, first of all, let's make our script. So let's create a brand new C# script for the delivery manager. Let's make a new game object to run it. So a new delivery manager, attach the script. Let's make sure to keep things clean, so reset the transform. And also, by the way, since we're here, let's go ahead and put the plates and delivery counter inside the counter so everything is nice and organized. Okay, great. So let's open up this script. Now here, basically we need to define some sort of list to store all of the recipes that the customers are waiting for, which of course begs the question, what type is that going to be? Now, technically, one thing we could do, since a recipe is really just a list of kitchen objects, over here we could have a list of kitchen object. This would be our recipe list. Technically that would work, but that really looks quite dirty. Instead of having a list of a list, we should probably have a proper type for this. So let's write some good clean code and define a proper recipe scriptable object. Back in Unity, let's go inside the scriptable objects folder and create a brand new one. Let's call this the recipe SO. And over here, let's make this a scriptable object. So extend scriptable object, make the create asset menu. And now over here for the fields, for the data that we need. Really, like I said, a recipe is just a list of ingredients. So just a list of kitchen object SO for the kitchen object SO list. Okay, that's it. That's really all the data that we need to define a recipe. Just to be able to identify them for the player, let's also add a public string for the recipe name. So just a nice name string. Okay, great. Now back in the editor, let's define. So let's go inside the scriptable objects and make a brand new one for our recipe SO. And now inside, let's create a brand new recipe SO. For this one, let's call it just burger. And over here, first of all, for the name, just name it burger. And then for the kitchen object list, well, to make a burger, first let's add some meat. And we want some cooked meat. We don't want to serve uncooked or burnt meat, so only the cooked meat. Then for a simple burger, obviously we need some bread, and that's about it. So some bread, some meat, that's our very basic burger. Now let's also make another one, so let's duplicate this one and name this one the cheeseburger. Over here, let's name it cheeseburger. And like name implies, has bread, meat, and obviously some nice cheese slices. So there you go. Okay, we have a cheeseburger. Now let's also make a mega burger, so something with everything. So let's call this one the mega burger. And over here for the string name for the mega burger. And for that we have meat, bread, cheese. Let's also have some nice cabbage slices and also some tomato slices. Alright, that's our mega burger with everything. And finally, let's also make just a nice simple salad. So let's duplicate this for a salad. Let's name it salad. And for the salad, we don't have any meat, we don't have any bread, and also no cheese. So just cabbage slice and tomato slice. That's a simple salad. Okay, so here we have all of our recipes. So back here on the delivery manager script, instead of making a list of game object, let's just make a list of recipe SO, and name it the recipe SO list. This is where we're going to place the recipes that the customers are waiting for. So let's actually rename this. Let's put it waiting recipe list, okay? So the customers are waiting for whatever is inside this list. And now we could make this a serialized field and set it in the editor, but we don't want to have a fixed list. We want to periodically spawn new recipes. And in order to spawn new recipes, we also need to know which ones we can spawn. So for that, we could add a list of all of the recipes. Then we could pick a random one from the list and add it over here to the waiting list. That would work, that's one good approach. But since we already did something similar to that various times in this course, here let me teach you a different approach that sometimes might make more sense. For that second approach, we just need one thing. We need a scriptable object to hold all of our recipes. So let's do that. Let's do a brand new C# script. This is the recipe list scriptable object. And then inside, this one is going to be a scriptable object. Let's add the create asset menu. And inside, we're just going to have a list of recipe SO. For the recipe SO list. So that's it, super simple. Now let's just create one object of this type. We can put it inside the recipe SO list since we're only going to have one. So let's make a recipe list SO, name it the recipe list SO. And then over here, let's just drag our recipes. So we've got a burger, a cheeseburger, we have a mega burger, and finally a salad. Okay, so basically we have a scriptable object with all of our recipes. And now, just for safety, since we only want to ever have a single one of these objects, a recipe list SO, for this one we can go back here in the script and simply comment out the create asset menu. So now back in the game, over here we can no longer create another type of recipe list SO. So just a nice safety thing since we probably only need just one. And let's also add an underscore just so it shows up at the top of the list. Okay, great. So we have this, and now over here on the recipe manager, we can basically expose that in a serialized field. So let's make a serialized field. Make it private of type recipe SO list, recipe list SO, for the recipe list SO. And now here in the editor, we just drag that reference. All right, that's it. So basically the difference that we did with this method is over here on delivery manager, instead of having a list of all of our recipes, we just have a reference to one object, and then that object holds a list of all the recipes. In this specific use case, like I said, this approach doesn't really have many benefits compared to just storing the list here. But let's say we had another script that also needs a list of all of our recipes. If we did that, we would basically have duplicate references. So this script would have a list of all the recipes, then some other script would also have a list of all the recipes. And then if you wanted to add a brand new recipe, you would need to add it to all the lists on all the scripts. Whereas like this, any script that needs to know about all of the recipes just needs a reference to the recipe list SO. And whenever we want to add or remove a recipe, we just need to update this one object and everything works perfectly. That's one of the benefits of this approach, where you have a scriptable object to hold a list of all of the objects of some type. Personally, I find this pattern to be quite useful. Okay, so on Delivery Manager, we have a list of all of our recipes. Now let's just make a simple timer to spawn them. Like I mentioned previously in the spawn point logic, you could just use a coroutine if you like that. Coroutines can be useful for running timers, but personally, like I mentioned, I do not like coroutines. I don't like the pattern they force you to use. So over here, I'm just going to make a simple float timer. So a private float for the spawn recipe timer, and another one for the recipe timer max, and let's say 4 seconds. Then we just do a simple private void update. On update, let's count down the timer, so time.delta time. And if the spawn timer is under 0f, let's reset the timer. And now let's basically spawn a recipe. So for that, let's grab a random one from the list. So we go into the recipe list SO and grab the recipe SO list. Then we're going to grab a random one. So let's get a random index. So random.range between 0 and the recipe and list so dot recipe so and list dot count. So you get a random one. This is going to be a recipe so for the waiting recipe so. And then we simply go into the waiting recipe so list and we add a brand new recipe. Okay, that's it. Super simple. Let's just make sure to initialize the list. So let's do here a simple awake for the waiting recipe so list and just initialize it. Okay, so like this, it should be working. However, we're also going to generate recipes nonstop. We don't want that, so let's define some kind of maximum. So let's define a simple int for the waiting recipes max. Let's say we can have a maximum of 4 recipes waiting. And then down here when the timer elapses, so if the waiting recipe so list dot count, if it is under the maximum, then we generate and add it. Okay, that's it, pretty simple. Now for testing, let's just add a log here to print the name. So debug.log on the waiting recipe so that we generate. So let's print out the recipe name. Okay, so let's test. So here we are, and yep, one was spawned right away. So we have a salad, and after 4 seconds, yep, there you go, another salad. And if we wait for 4 seconds, we should have another one. There you go, a mega burger recipe. And finally, after 4 seconds, we have another burger. And now, no matter how much time passes, there should be no more since we're at the limit. And yep, time passed and no more. Okay, all right, awesome. So we are correctly generating recipes that the customers are waiting for. Now let's add logic to try to fulfill these orders. So over here on Delivery Manager, let's make a function to deliver a recipe. So let's make a public void, make it public since we're going to access this from the delivery counter. Call it deliver recipe. And the recipes are going to be delivered whilst on a plate. So let's receive a parameter of type plate kitchen object. And over here, the logic is actually going to be pretty simple. We just need to cycle through all of the recipes that the customers are waiting for and see if the ingredients on this plate matches the ones on any waiting recipe. So over here, let's cycle through all of our recipes. So let's do a for int I at 0, going through the entire recipe list.count, I++, okay. Let's grab the recipe so for the waiting recipe so, and we grab from the waiting recipe so list on this index, okay, so we have that. Then first, let's do a quick test just to check if the waiting recipe has the same number of ingredients as there are on the plate. If not, then we already know that it's not valid. So over here, let's do a quick test. So waiting recipe so, let's check the kitchen object so list.count. If this one matches the plate kitchen object, let's get the kitchen object so list and also check the count. So over here we know that has the same number of ingredients. So this is the first check. Then we need to cycle through all of the ingredients on this recipe and all of the ingredients on the plate and basically see if both of them match. So let's first cycle through the ingredients on the recipe. So for each kitchen object so, let's call it the recipe kitchen object so. In the waiting recipe, so let's go into the waiting recipe and get the kitchen object list. Okay, so here we are cycling through all ingredients in the recipe. Then we need to cycle through all of the ingredients on the plate. So let's do another cycle for the plate kitchen object so, and we're going to go inside the plate kitchen object, get the kitchen object so list like this. So here we are cycling through all the ingredients on the plate. Okay, so now here basically we need to see if this ingredient that we're cycling through, if this one matches the ingredient on the recipe. So here we check if the plate kitchen object so, if this one matches the recipe kitchen object so. If so, then the ingredient does match. So in order to keep track if it does match, over here before we cycle through all the ones on the plate, let's define a bool for found or ingredient found. Let's default it to false. And over here, if we have a match, then this one becomes true. And by the way, over here, we can also break out of the cycle. Now, if you're not familiar with break, basically this is going to break out of the for each. So let's say the plate has 10 ingredients and the second one matches. When this cycle gets to the second one, it triggers a break, so it no longer goes through the remaining 8. So basically it breaks out of the cycle, so it keeps writing some code right down here. Okay, so we cycle through all of the ones on the recipe. Then we cycle through the plate, and if we do find that ingredient on that plate, then we have an ingredient found. So over here, if we have a not ingredient found, then over here that means this recipe ingredient was not found on the plate. So if that happens, then essentially over here we have a fail state. So the ingredient that this recipe requires is not on the plate. So let's go up here. When we have the same number of ingredients, let's define a boolean called the plate contents matches recipe. Let's default it to true. And over here, if we don't find at least one of them, then the plate contents do not match the recipe. And afterwards, we can check this boolean again. So if this one is true, that means they all match. If just one of them does not match, then this one won't be false. So over here, we know player delivered the correct recipe. So over here, let's do a quick debug.log and print out a message. And after we do, let's also do a return so we stop the rest of the execution. So basically, if we find a waiting recipe that matches, we don't want to keep going. And also here, if we do find it, let's also remove it from the list. So let's go into waiting queue, remove at, and remove at this index. Okay, so we're going to remove this recipe. But if this doesn't happen, then it's going to keep cycling, and it's going to cycle through all the recipes. So basically, if it reaches the end of this for, then basically no match is found. So the player did not deliver a correct recipe. So let's do another debug.log in here. Okay, so this is all of our logic. It looks a bit complex, but I hope this was easy to follow. When we see it in action, it all becomes a bit more clear. So all that's left is just calling this function from the delivery counter, so let's do that. Over here on the delivery counter, it accepts plates, it destroys plates, but before we destroy, let's go into the delivery manager, which means we need to access a reference. So again, we could add a serialized field, or in this case, it makes perfect sense to make this a singleton. So let's make it here, public static of type delivery manager, call it instance with a public get and a private set. Okay, then over here on awake, let's set instance equals this. All right, so now over here on the delivery counter, we can go into the delivery manager, access the instance, and deliver our recipe, and pass in the plate kitchen object. Okay, that should do it. Let's test. All right, so let's look in the log to see what they are waiting for. So there are 2 cheeseburgers waiting, another mega burger, and a cheeseburger. So let's make a cheeseburger to deliver. So first of all, let's cook some meat. Let's slice some cheese. Let's pick up the meat before it burns, pick up the cheese, and we just need the bread. Okay, this is a valid cheeseburger, so let's deliver it. And if there you go, the player delivered the correct recipe. Okay, great. Now let's deliver something that nobody asked for. Let's say just some meat. Actually, let's burn it just for fun. Alright, so there we have a bunch of charred meat, so nobody really wants this. But if we deliver, yep, there you go, player did not deliver a correct recipe. Alright, awesome, so over here everything worked. We have a bunch of recipes being generated. And then we have the logic so that when the player delivers something, it checks if the player delivered something correct or incorrect. So everything is great. All that's missing is obviously some nice UI, so let's do that in the next lecture. Hello and welcome, I'm your Code Monkey. In this lecture we're going to create a nice UI visual to display our waiting recipes. Okay, so our delivery manager is already working. We are randomly spawning some random recipes every once in a while. Now instead of looking at the console, let's add a proper UI. So for that, over here in the editor, let's go inside the canvas. And by the way, let's click on the button to unlock the canvas. And this is actually the first time we're using the regular canvas. Quite a while ago, we just created it. We didn't really set it up, so let's quickly do that. For the random mode, this one is meant to be a regular UI, so let's leave it on the screen space overlay. Then over here on the canvas scaler, instead of constant pixel size, let's go with scale with screen size. Then for the reference resolution, I like to use 1920 by 1080. And finally, I like to fully match with the height. Basically, this means that objects in the canvas will only be scaled if the height changes. For example, let's add inside just a quick UI image just to test. Let's look in the game view. So there you go, there's the image. Let's just put it on a different color. Okay, so there's the image. And note how if I modify the aspect ratio here, so let's say I put it on 5:4, there you go, the horizontal size of the window changed, but note how the element was not scaled. So I can put it even on free aspect, so really wide and does not change the size. Whereas if I modify this, if I modify the vertical size, the image does indeed get scaled up or down. Personally, I like the setup because it means that I only have to worry about positioning things horizontally. If the vertical part gets changed, everything gets automatically scaled. Okay, so great. So over here, let's go back into Full HD, all right, and let's get rid of the image, all right. Back in the scene view, let's quickly look at the canvas so we can select the canvas, press the F in order to zoom out, and also we can press the 2D button up here to go into 2D mode. Okay, so here's our nice UI. Now inside the canvas, let's create an empty game object, call it the delivery manager UI. Then in the inspector, let's make it stretch to occupy the whole thing. So let's put 0 on everything. Okay, so this window now occupies the entire screen. Now inside, let's do just like we did a while ago for the plate icons, meaning let's make the template that we can then clone, but let's also put those templates inside of a container. So first of all, let's make the container. So a new empty game object, call it just the container. The reason why I'm going with this approach is because I also want to have other objects outside of here. If you remember how we did with the templates, we can actually go there and see. So let's go inside the prefabs, inside the counters. Actually, it's on the kitchen objects. So let's go inside the plate. Over here for the template, basically we use the plate icons UI, this main canvas as the container. But if you remember how we did that, in order to make sure we didn't end up with duplicate icons, we always destroy the previous one when we spawned a brand new one. So every time we were cycling through the children of this object in order to destroy all of them except the template. So over here, we're going to use a container so that we can apply that logic only to the children of the container, and that way we can have other objects outside of the container. For example, outside of here, let's say we want some nice text just saying recipes in waiting. So on the delivery manager, let's make it a child of that one. Let's go into UI and let's make a text Mesh Pro. And this is the first time that we're using Text Mesh Pro, so this window pops out. Let's actually import the Text Mesh Pro essentials. Okay, just let it import. Okay, that's it. We don't need the examples or extras, so let's just close this window. And over here on this window, let's name this the title text. Let's set the text to something like recipes waiting. Let's put it up there on the corner, so let's anchor it on the top left corner. Also for the text, I like to put it on a width and height of 0, but of course that makes the text really vertical. So then down here on the wrapping, let's just disable it. So there you go, looks like that, and let's put it over there on that corner. Now in scene view, we are seeing things different. So if you want to see what this looks like, just go into the game view, and over there, yep, we do see the recipes. Let's just make it in bold. So there you go, just some nice text. Okay, so that's our text. And then for the container, let's make inside the delivery template. So let's create an empty game object. Let's call it the recipe template. And for this one, we're going to want to anchor it to the top left corner. So with the template selected over here in the inspector, let's click, and we want to click up here. However, we also want to set the pivot. So let's make sure to hold down Shift in order to set the pivot over there. Okay, great. That's exactly what we want. So we want the template right in the corner. Then let's give it a size of, say, 250 by 100. Okay. Now inside the template, we just need two things. We want the name of the recipe as well as the list of all the ingredients. Although before that, let's actually make a nice visual for the background. So a new UI image for the background. Let's make this one stretch to occupy the whole thing. Let's put everything on 0. Okay, that's the background. Let's put it on a black with just a little bit lower alpha. Okay, that's good. Then for the name, let's make a text field. So inside the template, let's create another text. Call it the recipe name text. Then over here, let's put it a bit small. So on a font size of maybe just 20, let's put it in bold. And let's also again put the width and height of 0. And over here, make sure to disable wrapping. Okay, so that's the text. So we've got it up there. Let's just anchor it to the top left corner. Okay, great. Over here, we can change the name to recipe. And then what we need is the icons down here. And for that, we're going to do pretty much the exact same thing that we did on plate. But before we do that logic, let's just get this basic setup working. So let's just position everything. So first of all, the container for all the templates, let's anchor it on the top left corner. And let's push it all the way over there. And for positioning them, let's use this time the vertical layout group. So inside, let's duplicate the template just to be able to see them. Okay, so that's pretty much what we want. We can actually set the width and height both to 0, and let's set the spacing to something like 30. Okay, so that's our basic UI. Now let's make the script to run this. So over here in our scripts, let's create a brand new C# script for the delivery manager UI. Let's go into the parent game object, and let's attach the script. Let's open. Okay, so now here, first we need a field for the container and another one for the template. So let's do a serialized field, private transform for the container, and another one for the transform, and this is going to be the recipe template. Then let's do pretty much the same thing we did previously. So first of all, let's actually go on awake in order to hide the template. So game object set active into false. Okay, so first we hide the template. Then let's make an update visual function. So private void update visual. And for updating, we're going to do the exact same thing that we did. So first, let's cycle through the container and destroy everything except for the template. So do a for each transform child in the container. And if the child is the template, if so, then we're going to continue. And if not, we're going to destroy the child game object. Okay, so we have the cleanup. Now all we need is to cycle through all of the waiting recipes. So that means that over here on Delivery Manager, we need to expose our waiting recipe SO list. So let's go down here, make a function to do that. Public, going to return a list of recipe SO, get waiting recipe SO list, and we just return the waiting recipe SO list. Okay, great. So now here on the UI, we can now go into the Delivery Manager, access the static instance in order to get the waiting recipe SO list. So let's cycle through this. So do a for each recipe SO in the waiting recipe SO list. And for each of them, let's instantiate and let's spawn our recipe template, spawn it inside the container. And then we just need to set this to enabled. So let's grab the transform for the recipe transform. We grab this one, grab the game object, and set active into true. Okay, so like this, the only thing missing is the text, but that's okay for now. Let's just see where we're going to call this function to update the visuals. And as usual, we want to be smart and write some good clean code. So let's not do the dirty approach of just updating this on every single update. Instead, let's only call this function when something actually changes. So over here on the Delivery Manager, let's just make some simple events. So public event handler. Let's call on recipe spawned, and another one, call it on recipe completed. And actually, as soon as I add the event handler, which also add the using system, now here we have an interesting thing. We've got a nice namespace collision. It's telling us that random is an ambiguous reference between UnityEngine.random and system.random. That is because both these namespaces, UnityEngine and system, both of them have a class named exactly random. So the code here does not know which class we're trying to use. To solve this conflict, we really just need to be more specific. In this case here, we want to use the UnityEngine version, so let's just write the full name, UnityEngine.random. And yep, that works. Okay, so now let's fire off the events. So first of all, the onRecipe spawns. Over here, when we spawn a recipe, let's invoke this event. So this event_targs.empty. And let's also get rid of the log, we no longer need that, okay? Now we could also add the waiting recipe on the event targs, but in this case we don't need it, just firing the event is enough. And then down here, when the player delivers something, if the player delivers the correct recipe, we remove it from the list. And then let's fire off the event, so on recipe completed, let's invoke with this and event_targs.empty. Okay, so we have the event, and down here we also don't need a log. Okay, so that works. And finally over here on the Delivery Manager UI, let's just make a private void start. On start, going to Delivery Manager, access the static instance, and listen to both these events, so the spawned, and let's also listen to the other one, so Delivery Manager instance on recipe completed. When either of these work, let's just go and update the visual. So just like this. Let's also rename this because again, instance doesn't sound like a very good name. Let's actually rename this to Delivery Manager, and same thing up here. By the way, I'm using the Visual Studio shortcut, Ctrl+RR, in order to rename this to Delivery Manager. And finally, we also need to update the visual on start, just to make sure the previous ones do not show up. Okay, that's it. So like this, it should be working. We should be able to see no visual, and then as more are spawned, we should be able to see each one being spawned until the maximum. So let's see. Just over here in the UI, let's make sure to drag the references, so the container and the template, and let's hit on play. And okay, right away, actually it spawned one recipe, it spawned instantly. Then after 4 seconds, there you go, a second one. And after 4 seconds, we should be able to see, yep, another one. Now 4 more seconds and we should see the final one. And now no matter how long we wait, it should no longer spawn anymore. And yep, that works. All right, awesome. So the basic logic is working. Now let's handle the proper logic on the template. For that, like I mentioned previously, one approach would be over here. You could go and do a transform.find, find the actual recipe name text, then get the text mesh component and set it. That would work, but like I mentioned previously, that would be very dirty, not good at all. We should avoid using find at any time, and we should also avoid the individual logic from the total logic. So let's do it properly and make a proper script to handle each spawn template. So let's create a brand new C# script. Call this Delivery Manager Single UI. Single just because it refers to a single recipe. And also right now we already have quite a few UI scripts, so let's organize our project again. So let's organize a new folder for the UI. And inside, let's put all of our UI scripts. So Delivery Manager Single, this one, the plate icons, and the progress bar. So let's put all of these nicely organized in the UI folder. Okay, so with the script, let's go into the recipe template and attach the script. Now let's open. And over here, let's begin by adding a field for our text. So a serialized field. And over here, it's also very important. For the text, we are not using the text inside Unity Engine.ui. This is the legacy text. It is not Text Mesh Pro, so this is not what we were using. Instead, we want to use Text Mesh Pro UGUI, which is inside TM Pro. So we need to go up here and add using TM Pro, and now we can use this type. And also make sure you're using Text Mesh Pro UGUI and not Text Mesh Pro. This one also exists, but don't mix these two. These are two very different types. If we go over here in the editor, and if outside the canvas, if I just create a new 3D object, a new text object, if I do that, then if we look over here in the inspector, we see this one is of type Text Mesh Pro. Whereas for the ones that we're using inside the canvas, if we look, this is Text Mesh Pro, it's a UI text. So these are the two different classes within Text Mesh Pro. You have Text Mesh Pro and Text Mesh Pro UGUI. We're working on the UI, so we want this one. Okay, so we named this the recipe name text. Okay, that's it. Over here in the editor, let's drag our reference, all right. So in the script, let's make a function to set the recipe. So a public void, and let's call it set recipe SO. And we're going to receive a recipe SO. Then we just go into the recipe name text, and we set the text to recipe SO.recipe name. Okay, so that's pretty much it. Now over here on the UI script, when we instantiate our recipe transform, let's get component of type of our delivery manager single UI and call set recipe SO and pass in the recipe SO. Okay, so let's see if the name shows up. And yep, right away it does show up. So we can see that we generated a cheeseburger recipe and right now a mega burger recipe. Okay, great. So all that's left are the icons down here. So like I said, that is going to be yet another usage of our template pattern. So inside the recipe template, let's create an empty game object, call it the icon container, and then inside that, let's make the template, and template is just going to be an image, so we can just create an image straight away. Call it the ingredient image. Let's scale it with a size of 40 and 40. Let's put an image by default, just like that. And on the icon container, let's put the width of 0, height of 0, and let's put a horizontal layout group. Put it over there on the left side, and we can create a bunch more just to see how it looks. Okay, so that's pretty much it. Now over here on the single script, let's add a serialized field, private transform for the icon container, another one for the icon template. Then we do the same thing as usual. So when we set the recipe SO, let's first of all clean up the container. So let's do a for each transform child in the icon container. And if the child is the template, then we want to continue and ignore it. If not, we want to destroy the child.game object. Okay, so that's a cleanup. And then let's do a for each kitchen object SO in the recipe SO.kitchen object SO list. Second through all of this, let's instantiate our icon template. Instantiate it inside the icon container. So this is going to be the transform for the icon transform. Then as usual, we need to go into the game object, set active in order to enable it. And also let's go up here, make a private void awake, and on awake the icon template game object, let's disable it. Okay, we don't want the template to be visible. Okay, so we instantiate the template, we set it as active. Then since this one just has an image, we can just do a get component of type image. That's image, not image conversion. So image, so it's this one, the one inside unityengine.ui. So let's get this image and let's modify the sprite and set it to this kitchen object so.sprite. Okay, so that's it, that should do it. Let's test. Over here in the editor, let's just go into the template. Let's drag the container reference and the template reference. And let's also rename this instead of ingredient image, put icon template just to be a bit more clear. And we can get rid of the other ones or leave them, doesn't really matter. Okay, great. So let's hit on play and see. And yep, right away it does work. So we can see a burger is composed of a burger and a bun, a salad, yep, there you go, some sliced cabbage and sliced tomatoes, then cheeseburger, same thing as the burger with some cheese, and then another burger. Let's just deliver until we see the mega burger. So let's deliver a cheeseburger. Let's cut it, get this, get some bread, place it in there, pick it up before it burns. That's a cheeseburger, so that one should vanish. And yep, there you go, it does vanish. Let's see if something else, not a cheeseburger, so let's keep doing until we get the mega burger just to see that everything works. So let's deliver a regular burger. Okay, now let's deliver a regular salad. Okay, just pick up like that, and drop it. Okay, let's see. And yep, there it is, the mega burger. Alright, great. So the visual logic is fully working and the delivery logic, all of it is working. So I can deliver the right recipes and get rid of them from the recipe waiting list, and more are spawned every time. Here we can see the name of the recipe as well as all of the nice icons. Okay, so with all of this, our game is really taking shape. Everything is very close to being done. One massive thing we're still missing is an obvious one, which is sound. So let's do that in the next lecture. Hey again, quick intermission. You're almost at the end, so once again, congrats for making it this far. This is the second secret callout. Go ahead, post in the comments a timestamp and a nice monkey emoji. It will be fun to see how many people make it to this point. By now you already know about the website. I hope it's been very useful to you. And you already know to ask any questions in the comments if you need help with anything. So all that's left for me to say right now is thanks for watching the course so far, and I really hope you've already learned a ton. There's only a bunch more lectures until we get to the final polished game, so let's continue on the next lecture. Hello and welcome, I'm your Code Monkey. In this lecture we're going to add some audio to our game, starting with a really nice music track. Okay, so our game is already looking pretty good, but everything is still way too silent, so let's begin by adding some music. Adding this is actually extremely easy to do. In the included assets over here inside the sounds, we've got a really nice music track. I hired the musician to make this, it sounds really good. It's a seamless loop, so to add to our game it's going to be super simple. We just want a constant, never-ending loop. So let's begin by creating an empty game object, call it the music manager. Let's reset the transform, keep things organized, and let's add a component, and we want the component an audio source. Here it is, this one. Like the name implies, this one acts like a source of audio. You will note how by default on the main camera, down here, it already has an audio listener. So the source plays some sound and the listener listens to it. Now over here, we just need to set these fields. So for example, on the audio clip, let's make sure to drag the music audio clip. Okay, great. Next over here, let's enable play on awake. We want it to start playing right away. And for this track, we do want to enable looping. Okay, great. Then for priority, basically Unity has a limit to how many sounds can be played at once. If you play too many, then some sounds won't play. And which ones do play is all based on priority. We always want the music to play, so let's put this one on max priority. Then for the volume, later on we're going to make a proper option screen to handle this. But for now, let's put it on something like 0.4 or 0.5, just to make a nice background track. Then we have here the spatial blend. For this music track, we want it to play the same regardless of where the camera is. So let's make this all the way fully a 2D sound. Okay, and that's it. We don't need to play around with any of the other settings. And just like this, if we are on play, and yep, there's the music. Now if you're not hearing anything, make sure that on the game view, first of all, that the game is actually selected. Make sure the scene is in focus. So over here I can move around, so the game is in focus. Then on the game view over here on the top right corner, make sure this sound icon is toggled. If not, then everything is muted. And also again, make sure, like I mentioned on the main camera, that it has the audio listener component. With all of that, yep, you should be able to hear the music. Now this song is playing and it will loop forever, just like we wanted. Personally, I really like how it sounds. I'm really happy with what the composer made. It perfectly matches the vibe of the game. So it really is this simple to add some music to the game. Let me just point out one thing also related to sound. One of the things you can make is an audio mixer. So for example, on the project files, let's create a brand new, and let's find over here the audio mixer. So there you go, here is an audio mixer, then you can double click to open up the audio mixer window. And then over here you have the master node, and then you can create multiple groups. So let's create a brand new group for something else. And then you can play around over here with the effects, with the volume, all kinds of things, all kinds of effects, everything. Then for each sound where you have the audio source, over here note how you have an output. And for this output, you can set it to play on the master, so it plays on everything, or set it on just one individual group. So with this, you could assign a group to one individual type of sound effect or the music or so on. Maybe you could even have your music split into multiple stems. So there's lots you can do, but for me, I'm not an audio engineer. Audio is probably the part of game development that I know least about. I just stick with the absolute basics. But if you want to learn more, definitely look into the audio mixer. This is an extremely powerful tool. But like I said, for me, I don't know how to work with it, so I'm just going to stick with the basics. So on the output, let's revert back into none, close the audio mixer, and get rid of this. And there it is, the music is playing, and it all sounds really nice. Alright, so here we very easily added some music to our game. This lecture is actually super short because it is genuinely that simple. Now the next thing that we need is going to be a little bit more complex, and that is adding sound effects. So let's do that in the next lecture. Hello and welcome, I'm your Code Monkey. In this lecture we're going to add some sound effects to our game. Okay, so previously we already added some really nice music, now let's add a whole bunch of sound effects. In the project files, if we go inside the assets over here, we've got all kinds of sound effects. Basically, I hired a really nice sound designer to make all of these, and I think they all sound really great, so let's add them to our game. Now, when it comes to sound effects, there are two main ways to play a sound. One is just like we did for the music, so we can create a game object, add the audio source component and play it. That's one approach, but that basically requires pre-preparing the sound objects. So there is another simpler way that just requires one line of code. So let's begin by making a sound manager game object. So a new empty game object for the sound manager. Let's reset the transform. Now let's make our script. So let's go in the scripts folder, create a brand new C# script for the sound manager. Let's attach the script and open. Okay, so now here let's make a function to play simple sound. So let's do a private void, just call it play sound. And over here, the way we play sound through code is actually super simple. We just go inside the audio source class. And in here, there's a static function, play clip at point. This, as you can see, takes an audio clip, a vector3 for the position, and finally a volume. So basically, it won't play that sound on that position. By default, Unity already has 3D sound, so if you play the sound on the left or the right side of the camera, it won't play in the correct place. Also for the volume, the further away it is from the camera, the lower it will be. And if we don't want the 3D sound, we can just play directly on top of the camera position. Okay, so in this function, let's receive our arguments. So for the audio clip, it's going to be our audio clip. Then let's receive vector3 for the position. And let's also receive an optional one for the volume. Let's just default this to 1f. Okay, so here we just pass this into our function. So the position and the volume. Okay, great. So now let's call this nice function. And for example, let's start with a simple one. So let's start with the delivery sounds. So over here on the delivery manager script, down here we have the logic for delivering a recipe. And over here we know when we completed a successful recipe or when we failed and the player delivered a wrong recipe. So this is where we want to play some sounds. And again, here we have yet another very important clean code question. We could technically call the play sound function directly from here. That would work, but of course that would make this class tightly coupled with the sound manager. For a simple game on this scale, that approach can work, just play sounds directly from the logic code. However, again, to make things properly, we should really separate the logic from the sound, just like we separated the logic from the visuals. So instead, let's not call the sound directly from here. Instead, let's make two more events. So let's make one on recipe success, and another one on recipe failed. Okay, so now let's fire off these events. So over here we have the success, so on recipe success. And if we get down here, then we have a fail. So on recipe failed. Okay, great, we have two events. Now back here on the sound manager, we can just listen to those. So let's do a start, go into the delivery manager, access the instance, and listen to the on success and on failed events. So listen to that one, delivery manager, instance, on recipe failed. Listen to both of these. Again, let's write some good clean code. So let's rename this one instead of instance. Let's put it delivery manager. And same thing on this one. Also name it correctly, delivery manager. Okay, great. So now when you have this, we want to call play sound. And now we want to pass in a reference to the recipe failed sound. So technically one approach would be up here to add a serialized field for an audio clip. That would work. But since we've already done that so many times in this course, here let's use a different approach that I also like to use. Let's create a scriptable object to hold a reference to all of our sounds. So similar to how we define the scriptable object to hold all of our recipes. Let's just comment this out just to make sure the code compiles. Okay, great. So back here in the editor, let's make a new scriptable object type. So let's create a brand new C# script for the audio clip refs scriptable object. Now here, let's make this a simple scriptable object with a create asset menu. Okay, so now for the fields, if we look in the S over here, the audio designer that I hired actually made several variations for each sound. So we've got multiple chops, multiple delivery fails, and so on. So back in the code here, instead of storing a reference for a single audio clip, let's store an array for all of them. So we have the chop, then we have all the others, so let's just add all of the references. So there's a chop, there's the delivery fail, then we have delivery success, then we have footsteps, then the object drop, then the object pickup, then we have the stove sizzle, although this one is just one, then we have the trash, and finally we have the warning. Alright, so these are all of the sound references we're going to use. Back in the editor, let's just create the object. So on the scriptable objects, let's create a brand new one. Let's make it of audio clip refs SO. Just name it audio clip refs SO. And over here, let's just drag the references. So let's use that quick Unity tip in order to unlock the inspector. Now I can select all the chops and drag them. All delivery fails, drag them. Delivery success, drag it. Then for all of the footsteps, after that are all of the object drops. Then the pickups, then we have the sizzle, which is just one. Finally, we have the trash and the warning. Okay, those are all the references. So our scriptable object now has all of the data we need. Let's unlock the inspector, okay. And back in the code here on the sound manager, let's make another version of this function. So let's make one play sound, except instead of receiving an audio clip, it receives an array of audio clips. Then basically we just call the other function. So we call the other play sound function and pass in an audio clip from this array. So let's actually rename this. So audio clip array. And let's pass in an audio clip from here. So do a simple random.range between 0 and the array.length. Pass in the position and the volume. Okay, so just like this, now all we need is a reference to our scriptable object. So a serialized field, private of the audio clip refs SO. Okay, we have this. Then here in the editor, let's just assign the reference, so the audio clip refs. Okay, great. And over here, when we have the recipe failed, let's go into the audio clip refs. And let's pick up, this one is delivery fail. And then the other one is going to be delivery success. For the position, let's just default to the camera.main transform.position. So like this, the sounds will play exactly on top of the camera. Okay, so let's test and see if it all works. Okay, so here we are, and let's do a wrong delivery. Now, quick warning if you're following along, or if you're just watching the video, this sound will probably be way too loud, but let's test. So if I just pick up the plate and I just deliver an empty plate, yep, there you go, there's the sound. And now if I deliver a correct one, so someone wants a salad, so let's cut a nice salad, chop that, chop this, pick up the plate, pick up that one and that one, deliver the correct salad, and yep, there you go, it does work. Alright, great. So the sound effects work, they played perfectly, but they're a bit too loud. Basically that's because these sounds were designed to be played in the world rather than on top of the camera. So when we play the sound, let's actually play it on the position of the delivery counter. Here is the delivery counter script. And based on our design, we're only going to have a single delivery counter, so we can just make this a singleton. So as usual, public static of type delivery counter, call it instance, with a public get and a private set. Then on private void awake, let's just set the instance equals this. Okay, so now over here on the sound manager, we can just grab delivery counter, and we just go into delivery counter and grab the static instance. And then for the sound position, we can just go into delivery counter, access the transform.position. Okay, so just like this on that one and on this one. Okay, so let's test, now it shouldn't be as loud. Okay, so here we are, and let's do a wrong delivery. And yep, it does work. Now let's do a successful delivery, so let's make a nice cheeseburger. So grab some cheese, slice it, grab a plate, just need some bread, and deliver it. And yep, there you go, it worked. Alright, awesome. Okay, so this is really it. This is how we're going to play our simple sounds. Now there are some that are going to require more logic, like the footstep sounds and the stove sizzle,